Let's take a look at the questions on homework number 14, starting with three-step linear equations. In this topic, you'll need to use your inverse properties and properties of equality to isolate the given variable. In our first example, we have variable x on the left side with the 4x, and we have the variable x on the right side with the 5x. So the first thing I'm going to do is I'm going to use my properties of equality to get my x's on the same side. So I think I'm going to subtract 5x from both sides, but you could also subtract 4x. I'm going to subtract 5x because I prefer my variables on the left. So when I rewrite here, I'm going to get negative 1x, or just negative x, plus 6 equals 7. So now I'm going to do the same with my constant. I'm going to subtract 6 from both sides. So now my x is now alone, or negative 1x if you will, and then isolate my variable so it's no longer negative by dividing both sides by negative 1. And that leaves me with x equals negative 1. And that's what I'm going to type here. Let's try this again. For this question, x minus 2 equals negative 3x plus 14. Again, I have x's on both sides, so I'm going to add 3x using my inverse operation and my property of equality. When I rewrite, I'm going to get 4x minus 2 equals 14. And although these first few problems are fairly simple, sometimes when you subtract x's from both sides, the x's eliminate entirely. That's not the case here. We actually have a solution, and that solution is 4. So we're going to type that in the box here. One last time. Negative 7x minus 9 equals negative 2x plus 31. Again, you could subtract either letter, or you can add either variable. So I'm actually going to do the opposite this time. I'm going to move my x's to the right, leaving me with negative 9 equals 5x plus 31. And then I'm going to subtract 31 from both sides, leaving me with negative 40 equals 5x, and then divide both sides by 5, leaving me with negative 8 is equal to x. All right, we're going to move on to the next topic now. Graphing lines from equations. And in this topic, you need to use your linear equation, x minus 3, and you need this number to begin graphing. On the y-axis, you will graph the y-intercept. Then from there, you will move 2 directions using the slope. If you don't see any numbers there, they are invisible ones. Remember, the numerator is the rise and the denominator is the run. So I'm going to rise up 1 unit and over 1 unit, put a dot. Up 1, over 1, put a dot. Up 1, over 1, put a dot. So when you use the keypad, you're going to click 1 time using the mouse, at negative 3, and then a line will appear. And go back to negative 3, move the mouse up 1, right 1, and click. Now I can submit my answer, and we'll do this again. Start graphing by using this value for your first point, then follow the slope of that value. If it is not a fraction, you need to put a 1 in the denominator. This is the rise, that's the run. The rise is negative 3, or down 3, and the run is positive 1, so that's here. Again, when I use my mouse pad, I will click once at positive 3, and then I will move down 3, right 1, and click again. In this problem, I'm going to start at positive 4, 1, 2, 3, 4, and now you'll notice my slope is already a fraction. It's negative 1/5. This negative sign can only be used 1 time. It can be given to the 1, or it can be given to the 5, but it cannot be given to both. choose which number you want to give it to. If you choose to give it to the number 1, then you will move down 1, but then 5 positively to the right. If you choose to give it to the denominator 5, you would move up 1, but then you would move left 5 units. Both of them would still lie along this same diagonal line. Okay? So again, when you're graphing, plot the positive 4 first, then move down 1, right 5, or up 1, left 5, both of which would be on the same line here. All right, let's go back and take a look at the third topic, writing equations of lines. So now the line is already given, and I need to calculate or use my eyes to find the y-intercept and the slope. The y-intercept is the easiest to find. It's where the line perfectly crosses the y-axis. So for us, that number is going to be positive 1. Now all I need to do is fill in this missing value. In order to compute that, I need to find the rise and the run between any two perfect corner blue points on this line. Choosing two that are closer together is easier because then you don't have to simplify or reduce a fraction. So it looks like my line is going down, so I know I need a negative number. Negative 1, 2, 3, 4, 5 down, and then positive 1, 2, 3, 4 to the right. There's my equation. Negative 5/4 x plus 1. Y equals negative 5 fraction bar fourths, arrow out to the side, and plus 1. Let's try this again. My y-intercept is 8. It's positive, and now all I need to do is fill in the slope number. I guess I'll use these 2 points right here. Looks like I go down 2, but I move over positive 1. I could write it like this, or I could reduce this fraction to say just negative 2. So here I'm going to write y equals negative 2x minus 8. Oh, sorry, plus 8. Plus 8. That was a typo here. I apologize. Plus 8. Make sure I fix that in my sentence. Don't want to get it wrong. There we go. All right, let's take a look at the fourth topic, comparing rates. So we need to read carefully here. It says the graph of a function is shown on the coordinate plane, and they want to know which one of these relationships, A, B, C, or D, has the same slope as the graph. So first I need to find the slope of the graph. So here's a perfect corner point. There's a perfect corner point. There's a perfect... All right. Now I can see the pattern. Down 2 over 1. Down 2 over 1. Down 2 over 1. That means that the graph has a slope of negative 2. I need something with the same slope. Well, the easiest thing to do is look at the equations first and look at the slope numbers. Are any of these negative 2? Yes, this one is. So that means A will be our answer. That was a quick one. If I didn't see it so quickly, I may have to do a little bit more math. Which of the relationships below represents a function with a greater rate of change than this one? This one has a rate of change of negative 3/2. I'm not exactly sure what value that is, so sometimes it is important to perform this math but with your calculator, negative 3 divided by 2. And if you convert it to a decimal, you might have a better understanding of how large or small that number is. So negative 3/2 is negative 1.5. So I need something that is greater than negative 1.5. So I'm going to look at this graph here, and it's negative 1, negative 2 over 1. So that's negative 2. And this one looks like it's negative 1, negative 2, negative 3, negative 4, negative 5 over 2. Okay, so let's see. Negative 2 This is my magic number up here, right? Negative 1.5. Negative 2 is actually lower, so that one's out. This one I'm going to convert to a decimal. It's negative 5 divided by 2 is negative 2.5, which is lower than negative 1.5. So these two options are out. So let's scroll down and take a look at the other two options. These are tables, so I have to look at the patterns or just compute with a giant subtraction fraction. I'm going to compute here, negative 2, negative 5. I'm going to compute here, 4 and 8. And it looks like I'm going to get 3 over negative 4, which is negative 0.75. And on a number line, negative 1, negative 2, negative 1.5 is here. That was my magic number. And negative 0.75 is here. So this one is definitely greater. So C is my answer. One more time. Which of the relationships below has the same rate of change as negative 3? So let's see here. I've got 20 minus 8 and negative 4 minus negative 2. That's going to be 28 over negative 2, which is negative 14. Oh, that's definitely not the same as negative 3. Let's see what we've got here. 1, 2, 3, 4, 5, 6, 7. 7 down. 1, 2, 3, 4 over. That is negative 1.75. Definitely not the same. So let's keep scrolling. Let's see what we've got here. We've got an increase of 2, an increase of 4. So 2 over 4 is 1/2. And my original equation was negative 3. So that's wrong. Down 1, down 2, down 3 over 1. This is the winner. Negative 3 over 1. All right. Oops. The answer was D. All right, let's head back and take a look at these last two. Determine if a set of points is a function. So in order to be a function, you have to have no repeating x values with different y values. So it's okay to repeat the x values, but you can't repeat x's with different y's. So let's take a look at our first option here. I have 8, negative 2, negative 8, and negative 8. So I've got some repeating x values, and their y values are different. So this one is not a function. Let's take a look at the next one. I have some repeating x's with different y's, so this one is also not a function. How about this one here? Oh, all unique x's, no repeating x's. So that must mean this one is the function. Let's double check over here. Yep, there's my repeat. There's my different y's, so that one is out. So we're going to select and submit. Again, we're going to scan the x values only. And this time we're looking for one that is not a function. Well, this one passes, no repeats. This one passes, no repeats. This one passes, no repeats. Oh, this one right here. Got a repeating x with a different y, so it fails. It is not a function. All right, let's take a look at the last category. Determine if a graph is a function. So the only way to determine if a graph is a function is to take a straight vertical line and to move it across your graph and see if it touches in more than one location, which this one totally does. So this is not a function because it fails the vertical line test. Let's take a look at another graph. Again, you draw yourself a vertical line, you scan it across. If it touches more than once, it fails the vertical line test, and it is not a function. This is not a function. So you can use a pen or pencil to hold it over the screen And as you move across, as long as your x and y values as long as I'm scanning this, I never touch the graph twice, then I pass the vertical line test. This one is a function. One last time, take your vertical line, scan it across your graph. As long as you never touch the graph twice, then you can pass and you are a function. Click function and submit. All right, good luck with homework number 14.